Hi, I'm Mike with House on the Mend, and in this episode of our ongoing van build series, we're going to be focusing on the initial stages of our electrical system. So I'm going to talk about this rack that I built to house the batteries, and we got a wheel well here, so underneath I have hidden all the electrical components. So if you think this might be helpful for you, will you please give it a thumbs up? All right, let's get started.
House on the Mend.
So for our electrical system in this van, you know from a previous episode that we've put 700 watts of flexible solar up on the roof. Very low profile, so I can still go through drive-throughs and things like that. I can still park in our garage without ripping off half of our work. Now down here into the bay of the van, we've got three 200 amp hour batteries. These are lithium ion phosphate. These are ampere time batteries. I got them off of Amazon, and after watching a couple reviews, the only concern with these batteries was the battery management system inside did not have a low temperature sensor or freezing sensor. So the way I circumvented that issue with still going with very affordable batteries is to use Victron components for the charger, the smart shunt, and this little guy right over here that will be set down on the batteries and is a temperature monitor and will stop the charger from charging if the batteries are at or near freezing. Now, the other components I have are smart shunt here. I have two big bus bars. I have emergency shutoffs right here by the door for both the battery and the solar panels. In this drawer here, I have a breaker headed to the DC system, and then two things over is going to be our next episode where I'm going to put in a 3000 watt inverter. So in this episode, I want to show you all the various components of this rack made out of 80/20, how I made the doors, how I bolted everything to the doors, and the reason why I hid everything in this manner where it's still accessible, but it's not out here where things can bump into it, as is, if you remember, during most of the work week, this is my work van. I have all my tools set right here underneath what will eventually be the bed. So I don't want to be sliding tools and things in and out of here, ladders and whatnot, and have anything arc off on my electrical system. So I want it, of course, accessible with the doors, but not exposed. And so this is the system I came up with, and we'll go through all the components. So this is the cage that all the electrical is going to be housed. It's obviously made out of 80/20 extruded aluminum. And then I used beadboard plywood for all these front panels. These cool little red latches are how I hold it up. And then I have piano hinges there on the bottom. We'll talk about all that. Let's move around first to the back. This is where, when you open the door to the van in the garage, you will see this view right here. And so with just merely opening the van doors, we can get to the emergency shutoff for both the battery and the solar. Now, let's take a look inside how that's wired. Big robust double-aught cable. I'm going to adjust the ISO here a bit. There we go. And each of those shutoffs goes right to a fuse. One of those is obviously going straight to the is straight from the solar and then going to the solar controller. The other one is coming down from the batteries. Oh, and I hold these in place, if you see right here, with angled aluminum that I just put a little bit of adhesive foam weather stripping on, and those are working really good, nice and quiet. All right, we come around to this one here, and when we open that up, we have access to the solar controller, and then the two bus bars, the positive and negative. Coming off of the positive, we have this one, which will be going to the inverter. This one here is going right to the next panel for the DC bus. This line here is going up to the charge controller, and then this one is coming down to the bus bar from the basically from the battery. If we step over to the negative bus bar, we have this one that's going to be ground to the van once we load it into the van. I have two lines here, one going to the charge controller, the other one going to the next panel over, which is the DC controller. This one here is yet to be hooked up, but that's going to go to the inverter. And then we have the one coming straight from the battery to this side of the smart shunt, and then hooked up to the bus bar itself. If we step to the next one, we have the line coming in to a fuse breaker, and then jumping across here to our whole DC circuit panel. And then this is the negative coming in from the bus bar. Now originally I thought I would do the positive bus bar on this side and then the negative bus bar on this side, but come to find out I had more than enough room on that first panel, so this one here is actually going to end up being storage. And it'll be about 12 inches deep and about 18 inches or so wide and tall, so it's going to be a nice little piece of storage. So all the connections are with this very nice wire. I'll leave links in all this. This is all stranded wire. You don't want to do solid core. And all the lugs here that you see, I crimped on myself. And then after crimping on the lugs, I put shrink wire on there, and then put conduit, plastic conduit, to protect it from any kind of wire chafing. Let me show you exactly how I do that and all the tools involved, and we'll make a couple pieces right now. All right, let's talk about the wire. It's cutting, it's crimping, and protecting with the heat shrink wrap. Let's go over all of it. So the biggest wire I'm using is 2/0 or double aught. And that is really thick. This is a big battery cable, also what welders use. Now, I am using stranded wire. You never want to use solid core in any size in your van, because the stranded wire holds up better to the vibration of driving around over land. There are at least a couple types readily available of this big double aught. The stuff that you buy in Home Depot, or I bought this in Lowe's, is stranded, but you can see here it's big strands that are wrapped together. This stuff is going to be good for runs that are relatively straight, but if you're winding around or any kind of curves or bends, this stuff is flexible, but it's not very friendly. Way better is this awesome stuff right here. This is Windy Nation PowerFlex. This is the kind of cable that they use for welding, and it is super supple, and yet it's the same thickness core. So I love this stuff. I'll leave links to this. You can buy it in kind of short little runs if you want, like I did, and if you do so, it comes with a little pack of the lugs and some of the heat shrink. So this stuff is the best, available on Amazon. Heat shrink, like I said, this came with the kit. If not, you can buy it in a thick enough gauge. It looks like overkill, but it'll go, the lug can easily fit over it, right? So that's why it's so big. If you get stuff that's a little tighter, just slide it on first and then put on your lug. To cut this wire and anything smaller, I purchased this ratcheting wire cutter. And you bring this around, you set it, and then with one hand, I can ratchet even this double-aught cable. I bet that heavier stranded stuff I bought at Lowe's might take two hands, but this stuff I can do one-handed. My only gripe with these, because otherwise they work great, is when you get to the last tooth right there, it looks like it goes all the way through, but it always leaves a little bit of the insulation left that you have to kind of pull off of both sides. If I had one critique on these ratchet cable cutters, it would be to put another tooth in like that, so it would really pierce the full strand of the wire, including the insulation. But it's really easy to reset. You can just wrap it right back around again after you cut it and start over. So I do like these. All right, we're gonna need scissors for cutting our shrink wrap. I have a knife that I'm gonna use to cut off the insulation. Then we come to the crimpers. So I love these crimpers that I bought. When they're done, they have like an octagonal crimp on the lug, and it's just so professional looking. I think it's great. I only have two gripes about this little handheld unit, because I can do even these big ones by hand really easily with the mechanical advantage and the hydraulics of this. My first gripe is that the on and off to me seems to be backwards. So you have to turn it to off to actually make it work. And then when you want to release it or take it off, you have to turn it to on. So that sticker's backwards in my opinion. I am left-handed, so write in the comments if somehow I'm mistaken. Now it comes in this really nice case right here. And it comes with all these various different size crimping lugs, which is great. It wasn't very expensive at all. This is definitely not a professional set in my opinion. It's something for hobbyists like you and I. My second gripe is that this chart right here, so if you're using, in our case, double-aught wire, it says to use the size 70 die. That is this big one right here. Well, if you use this die for these double-aught lugs, you can actually pull the wire out. It doesn't crimp it enough. And I have found with every gauge I have used it for, so double-aught, 4 and 8 gauge, that I've needed to go down one step from this chart that they gave. So luckily we have the die, so it's not a big deal, but that's why it's a minor gripe. Once we're finished making our cable, I want to protect it a little further than the insulation with this plastic conduit. Now there's two types. There is the most typical type I've ever seen, which is this, which is called split loom, where they've cut it for you so you can get it, right there around the wire. But they also make, and watch out for this, they also make solid loom. And I bought some of that and it doesn't fit through there. So if you end up mistakenly buying that on Amazon, it's no problem. You can just take a pair of scissors like I did with a different piece and just go and cut it. It cuts really easy. For this instance here, this is going to be the cable going from the battery shutoff up to the positive terminal of the battery. So there's actually a couple sections that I want to leave relatively exposed. One section running down the door, or the access door, because I want to be able to put a cable tending clamp right there to hold it onto the wooden door. And then when we get up to where it's going to come around and go across to get to the battery terminal, I want to have there be no mistake that this is a positive cable. So in this case, I'm just going to put the conduit over a smaller than typical portion of it, but we're going to go through that, how we do that here in just a second. And I have really come to like so far this fabric tape rather than electrician's tape. When you pull apart electrician's tape, that part that stretches tends to curl and it loses some of its adhesive value on, in my opinion. So unless you want to cut it constantly with a pair of scissors, which obviously you can do, I have come to really like this. This was suggested by the Amazon site when I was buying the conduit. And this stuff is really easy to tear. So when you're working right here, you're not having to switch over and pull out a pair of scissors or whatever. I think it's working great for me so far. We'll see how it holds up. So let's get to crimping on this terminal. This one here, this big 3/8 lug is going to go on the battery itself, but I have this smaller 5/16 for the breaker fuse. Now, we want to cut off this insulation, and what you do is just measure right about to there. It doesn't compress very well into here, so it's better to be just a little bit past, because we're going to cover that up with heat shrink later. So if you want to go a little past that, that's what I have found is pretty successful. And you can see right here with a Sharpie, I made that mark. So let's grab my razor knife here, and I'm just going to cut around. This has got the thinner core wire, so just be kind of gentle going around. All right. So I like to give it a twist like that when it's starting to come off to pre-twist that cable. Then we need to think about the what the cable wants to do. So it's been like this in packaging for who knows how long. It's been rounded this way. I know that this lug is going to be coming down and winding and coming and making a turn immediately. So I'm going to want this lug to be right here to follow that natural bend that it already has. So with that in mind, let's mark right there and right there so we know to line it up. This is an extra step. I'm just being anal, but I have found it makes it a little bit easier. Then we can preload this guy, turn it to off instead of on. I'm going to get it started just right to the end of that horn where it's just biting. And now we've pre-spun it. We pull it off and it goes right into that lug. Look at that. Nice. All right. I'm going to hold it in tight. Got our lines right there together, and I'm just going to start going. You can see the jaws starting to compress. And that is really not that difficult. I'm resting on the top of my contractor's table saw here, and it is not that hard. When you get to here where there's just like tiny little fractions of a millimeter left and you give those pumps, then it gets a little tougher. But once it's completely compressed, that's it. We turn it to on instead of off. And what we're left with is this really tight lug, which is great. All right. Now we want to cover this connection. This one here is probably a little bit better. See, there's only a small reveal, but nonetheless, we're going to cover those up. So let's cut about this much. All right. Now this stuff is big enough you can just slide right over the lug. And that's all that's left to do is take a heat gun. This stuff has adhesive inside of it, and you'll see it bubble and be visible on the end here in just a minute. Isn't that nice? And there we go. Nice, clean, professional look. There we go. On the driver's side, in the very back of the van, is where the electrical cage is going to go. And if you see that straight foam adhesive that's going all the way along, that is where the cage is going to sit attached to the van. And I want to have a thermal break there, so not only am I using rubber washers at each of these riv nut locations, 1, 2, 3, but all of this right here is this adhesive foam backed insulation that is very widely available. It's made by Frost King. I got this stuff at Home Depot. And you can see that this is just the wax paper that protects it here from the adhesive, but it's a nice cushy foam, and then on one side is the adhesive. And we are about ready to put the batteries in and start wiring those up. So before I do that, while we still have the advantage of taking a look down through the bottom here, let's take a look at some of the items and how I installed them. And from the shutoffs, we have this positive that's going to go across the battery and hook up to the first battery. This little guy here is going to supply power to the smart shunt. So the smart shunt gives us all kinds of great data about how the batteries are doing and how the solar panels and the charge controller are doing. And it has this little green guy right there that has 2 wires coming out of it. One of those wires is the one I just pointed to that supplies it with battery power. It also allows the smart shunt to track the well-being of that first battery. This auxiliary line right next to it is going to come over here, and I have this wire that'll come across and attach to the second battery, and it can also monitor the health of that battery. Well, we're going to have 3 batteries, so this one over here I am going to put on an auxiliary unit that is also made by Victron, and that one will also, in addition to the health of the battery, will also keep track of the temperature. And then while we're down here, here is the negative line, and that's going to go to the negative terminal of the third battery. And that way we are not drawing mainly from this first battery. The positive is going to be over here linked together in parallel, and the negative is going to be down on the third one linked this way in parallel. All right, these straps are the support straps. I've just got them set here while I've been driving the van, but we're going to pull those back and set them out of the way. We're going to put the batteries in here, and then I'm going to set up and start wiring each battery in parallel. Ooh, that looks pretty, doesn't it? 600 amp hours of batteries. So to help give you a little perspective on the size and capacity of our system, we have 3 200 amp hour batteries that are lithium iron phosphate. When you put those in parallel, that turns out to be 7,200 watt hours of usable energy. So let's compare that to the very popular EcoFlow Delta 2 Max. That is 200 watt hours. So you would need 3.5 of those at $1,700 each to equal what we have on board. And even if you go with their biggest system, the EcoFlow Delta Pro, that's 3,600 watt hours. So you would need 2 of those at $3,000 each to equal the capacity we have on board. Now you might be asking yourself, Mike, why do you need so much capacity? And it's true, when I was a young military man on my own, all I needed was a can of soup that we would place on the hot intake manifold, and we would shower with jerry cans or buckets of water when we were out in the field. However, nowadays I tend to travel with at least 3 women, my wife, my 2 daughters, and on occasion our granddaughter when we go camping. And when you consider that they have a certain level of comfort expectation above the mere man, air conditioning, hot water heater, hair dryer, flat iron, and charging devices, 3 women is going to equal approximately an infinite watt-hour capacity need. So for each one of the batteries, I'm going to be installing one of these terminal fuse blocks. So I've got fuse blocks throughout the whole system, as you've already seen, but I'm going to add another layer with one of these at each of the positive terminals. They're rated from 30 amps to 300 amps. So that should give us some really good protection. All right. Got everything custom made and hooked up. That little guy you see right there is the temperature sensor and battery monitor for this 3rd battery. Everything's still shut off, and now that it's all hooked up, we're ready to flip the switches and start programming the charge controller. All right, moment of truth. We are going to turn on the battery supply, get the charge controller going, start programming it, and then turn on the solar system so it can start charging the batteries. Now, I'm pretty confident in all my connections, but I got a fire extinguisher right here just in case. And I went through before this point, and I went through and reviewed all the connections, made sure everything was right, and I'm glad I did, because there's actually a little spot on the charge controller that's also supposed to be directly grounded to the bus bar. And I was able to catch that and had to go back. It's a super pain to get in there. It's a really tight spot, as you can see here in this video. But I made a line out of 8-gauge wire and connected that to the bus bar, and now we're ready to go. All right, so I'm going to turn this battery on. I got safety glasses on just in case. And that was pretty anticlimactic, but battery's on. I'm going to look down here and see if I see any lights coming up on our battery, our controller. I'm going to take some readings with this voltmeter to make sure that we're fully charged and running here. And I'm not getting anything. Well, I figured it out. These fuse blocks that I ordered from Amazon had the picture of the actual fuse piece on them when I purchased them, but when they showed up, it was just the terminal block, no fuse, and I'm past the time I can return it. So I ordered 100 amp fuses to go on here, and they'll be in tomorrow. All right, 24 hours later. The bus fuses just arrived, 100 amp fuses for each one. That's what the battery manufacturer recommends the maximum draw should be, so therefore that's the fuses I chose. I've got the door open, got the voltmeter ready, and I'm going to take measurements to make sure we're getting power to everything. So let's go ahead, I got the fire extinguisher, let's go ahead and crank this guy on and see what happens. Okay, now this time I can see that little battery monitor over there that eventually is going to be moved back as like a freeze detector, but I got it up top now so I can look at it. I can see the blue light blinking on that. That's a good thing. That means that guy's got power to it. Oh, and I see a blue blinking light on our charge controller. Let me make sure it's getting the accurate amount of power. Yep, 13.26, which I tested each of these batteries individually. They each had 13.27. So when you go through the resistance in the system, it's only bringing it down by 0.01. That ain't bad. All right, so we're good to go there. Before I turn on the solar panels though, I want to go into the app and I want to add the charge controller, add the smart shunt, add that little monitor over there, and then the battery manufacturer supplies me in their little brochure with all of the various settings that Victron lets you adjust so you get the best amount of health in the recharge and draw of the system. So I'm going to fire that up now and program all that in. So look at that. No sooner did I fire up the app than it recognized all three Victron devices I have. The solar controller, that little battery sensor, and then the smart shunt. So that's great. Let's go into this guy and let's start programming it for the batteries. From my understanding, its default is 4 zeros. So let's update the firmware. Oops, there we go. All right, now we're updated to 3.07. That's quite a different number from the last one. Okay, let's see if we can get into it now. All right, let's see if we can go into the settings. Yes. Battery is 12 volt. Max charge current is 100 amps. And I know that because this handy little brochure tells me that the max charging current is 100 amps. So let's hit OK. All right, I changed the absorption voltage to the charging voltage of 14.4. The float voltage is right here, 13.8, so I changed that. Low temperature cutoff. So here's our working temperature range. For charging, it's 0 to 50 degrees Celsius. For discharge, we can go all the way down to be operating at -20 to 60. So prevent damage to lithium batteries by disabling the charger during low temperature conditions. All right, so let's go by charge condition. So we can actually go down to 0. Well, let's just leave it at 1 just to be safe. Well, I guess it auto saves. I would love to name this, so let's go in here and save that setting to ampere time. So now let's go into the smart shunt, and of course there is a firmware for this guy. Just like the charge controller, this had to be updated twice because there's been at least 2 different versions here. And you know what would be great is if we can bring in the settings that we already changed, right? Air loading files. Oh man. So they're not interchangeable. All right, let's go in. We're going to set everything the same. Now, discharge floor is a lot higher than 50%. 50% is when you're dealing with lead acid batteries. All right, so right here we got battery voltage stays above 12.5 at 90% discharge. So that's still high enough to run most of our devices, right? Operating voltage is 12.8, 12.5 is 90% discharge. Let's go ahead and change that to 90%. All right, everything's pretty well programmed in. Now it's time to turn on the solar panels and see if they start registering. So I'm going to walk over and do that right now. Solar panels are now on. There we go. So remember from the other video, we've got 4 solar panels up there, 700 watts. Each one was in the 20, 21, 22 volt area. And when we first turned it on, it was looking like, what, 85 volts, which would have been right about correct. There, yeah. So at or near the end of every video, we've been keeping a running cost and how much weight we've added for each portion of this build, since the Ram Promaster 2500 has a capacity of roughly 4,000 pounds. So for this particular portion of the build, I couldn't do a cost breakdown of the cage. There was just too many components when you consider all the little fittings and fixtures. If there's any interest in that cost breakdown of the cage, when I do the video for the other side of the van, when we do the plumbing, I'll break down and show the differences in the ways to save money in some of the 90-degree angled corners and things like that. But I did a rough calculation of the weight when you consider that every inch of extruded aluminum is 0.079 pounds. And you add that with the hardware that's in there, including all the doors, we're talking roughly about 75 pounds there. The 3 batteries that are no longer called Ampere Time, they're actually called Li Time, were $1,890, adding 137 pounds. The Victron charge controller was $590, adding 7 pounds. The Smart Shunt was $130 and about a pound. Now for the stranded wire, I used double-aught, 4 and 8 gauge wires throughout this system, costing me roughly $120, adding around 15 pounds. The 2 bus bars were $35 and only added about 2 pounds. That gives us a subtotal for this portion of the build of $2,765, adding 237 pounds. When we add in episodes 1 through 5, we get a total of $7,596 so far, adding 856 pounds. All right, so there we have it. If you found this video helpful, will you please give it a thumbs up? Really helps the YouTube algorithm to start suggesting it to more people. There were a lot of firsts in this video for me, using this Victron system with Bluetooth technology to track how the solar panels and the batteries are doing right off your smartphone, all these shunts and bus bars and things like that. So this was very educational for me. I really enjoyed it. If you have any questions, please leave them in the comments below. I'm going to leave links for everything that I bought off of Amazon so that you can check out those links. Full disclosure, these are affiliate links, so if you click on them and end up making a purchase, it won't cost you a thing, but I do get a small reward at the end of the month. It helps to justify all the time it takes to set up the camera before producing each piece of equipment here, and the cost of producing videos like this. Until next time, when we work on the inverter over here in this structure, thank you for watching.